So for today's lesson, we're going to continue about light. Last time we talked about light energy. In that lesson, white light was part of our discussion. But now we're going to take a closer look at the white light. Okay, let's begin. Son, can you please read the first paragraph? Okay, very good. So you actually learned this already in our last lesson. So this is just like a quick review. So light bounces off many materials. This process is called reflection. Light can also pass through some materials and bend as it comes out the other side. This is called refraction. So just like last time, okay, I showed you this short GIF. Okay, so this is reflection, bouncing off the surface of objects. Refraction is, of course, the blue side, the royal blue. So it passes through, okay, the object. And we're going to learn more about that today. Light from a bright object, such as a light bulb, is considered white light. The light is actually composed of all the colors of the rainbow. So if you can remember, the white light is actually the combination of the colors in the rainbow. Okay, so it's not really pure white. It has many types of colors within it. Okay, and just a quick review again. The other types of light, okay, these are the ones that we can't really see. Okay, so this is in the spectrum of light. Okay, so continuing. Okay, let's take a look at the second slide. Okay, transparent and translucent. Okay, maybe you already know the meaning of transparent. I mean, especially transparent, but maybe a little bit more on translucent. So light passes easily through air, water, and glass. These things are transparent. Transparent materials don't interfere with the light passing through them. Okay, so just like glass, water, and even air, okay, light can go through it, okay, easily. Next one, if only a fraction. Okay, a fraction means like a small amount of something. So if only a fraction of the light can pass through a material, the material is said to be translucent. Okay, translucent include colored glass, rocks, minerals such as quartz and mica. Translucent materials will block some light and let some light through. So just a little bit of light passes through it. Look for objects around your house or school. Try to determine whether they are transparent or translucent. Okay. So here, I'm going to show you this video later. But for now, okay, let's just read through these. So, okay, next part. Okay, next one is opaque. Many materials are too thick or dense to allow light waves to pass through them. These materials are classified as
Opaque.
opaque. Materials such as metal and wood don't allow light waves to pass through. Sometimes these materials will reflect much of the light back. Okay? Look around your house or school for materials that are opaque. Which ones also reflect much of the light? Okay, so we have transparent, translucent, and opaque. Okay, so through this video, we will try to visualize, okay, these three objects, transparent, translucent, and opaque. Okay, let's try to play it.
Objects are classified as transparent, translucent, or opaque depending upon their treatment of light.
Can you hear that?
Yes.
Okay, let's try to watch it. It's just 1 minute.
Objects that allow light to pass through them are called transparent objects. Most of the light falling upon a transparent object passes through it to the other side, thereby allowing us to see through them. Glass, clean air, pure water, etc. are examples of transparent objects. Objects that do not allow any light to pass through them are called opaque objects. As a result, we cannot see through them. When light falls on an opaque object, its shadow is formed on the other side of it. Wood, sheets of metal, dark-colored plastics, rocks, etc. are examples of opaque objects. Objects that are partially transparent and partially opaque are called translucent objects. They allow light to pass through them in a scattered or diffused manner. Frosted glass, tracing paper, greased paper, etc. are examples of translucent objects.
Okay, so there you have it. Okay, a little bit more about the three objects that we have. Sorry, Son, it's a little bit dusty here. Um, Son, can you think of things that are transparent?
Glasses are transparent.
Mhm. What else? Glass. Hmm.
And
How about and?
water.
Yes, and water. Very good. How about objects that are translucent? Mm.
Frosted glass.
Frosted glass. Yes, very good. Just like this one. Okay, what else? One more.
And dirty glass.
Yeah, okay, it can be. Okay, dirty glass as well. Okay, and how about opaque objects?
Wood and metal.
Yeah, wood and metal. Okay, yes, those are the things that light cannot pass through. Okay, opaque objects. Okay, next one. Okay, anyway, this is just a very quick lesson. It's almost common sense actually. So do you remember? Anyway, you don't need to do this because the flashcard is too easy, only part of the light. You don't need to answer this anymore. Okay, instead, we'll just go forward with the lesson. Okay, wait. Okay, so let's try to answer this on. Materials are too thick or dense to allow light through are called what?
Opaque.
Yes, opaque. Good. Number two, light from a bright object such as light bulb is considered a what?
Mm, transparent.
Okay, transparent. Not really. It says here
Uh,
light.
white light.
Yeah, okay, the white light. Okay, number three, light can blank off of some materials. Hmm.
Mm,
Do you remember the bouncing motion?
reflect.
Okay, reflect. Okay, very good. Yes, reflect. And number four, light can also pass through materials and when it passes through,
Mm, and refract.
refract. Okay, good job. That's it. Okay, so that's it for this lesson. Any questions on?
No.
Okay, good job then. Okay, next. Wait. Yeah, this is just a little bit more. Okay, transparent, translucent, and opaque, just like the apple. Okay, next. Um, we're gonna go to the second part of this lesson. Later, we'll move on to measuring waves. These are just very short lessons. Okay, in the second part, this is actually repeated again, but let's try to get more ideas only on the first slide. So it says here, light travels in a straight line. Okay, that's always true. They always travel in a straight line. It cannot travel around objects. Okay, it cannot actually do that. Okay, so sometimes light is bent when it travels through a material. but its natural tendency is to travel in a straight line. Because light travels in a straight line, it is easy to block. When you block sunlight with an object, for example, you can create a shadow. Can you think of other examples of shadows? Making shadow puppets by shining a light behind your hands and then watching the shadows on a screen is a great example. Another example is the solar eclipse. Do you know what an eclipse is?
Yes.
Yes, okay. So the moon moves between the sun and earth, and when the moon's shadow passes over earth, daylight turns temporarily to nighttime until the moon and its shadows move on. In a lunar eclipse, you can see Earth's shadow on the moon, as Earth passes directly between the sun and the moon. As these examples show, shadows can be small or large. Okay, so the question is, Son, just for speaking, how do you think are shadows created?
Like the light cannot pass through us.
Mm-hmm.
So, like the body's job is like making a barrier between light. So in the table or a screen, the light cannot pass through it. So the screen is black, and that is called shadow.
Okay, nicely done, Son. Okay. So, yeah, these are just normal things that happen in our life. But when we try to explain it, sometimes it's a little bit difficult. But for you, you explained it well. You're correct. So, just like the body of this man, it forms like a type of barrier and it prevents the light from traveling into a straight line. So, creating the shadow we see. Okay, anyway, this is just for entertainment. Okay, so the next parts of this lesson you can see that this is actually just repeated of your first lesson a while ago. So of course we'll just skip this. So transparent, translucent, they even have the same picture. Okay, instead, okay, we'll just take a look at these. Okay, so test the following objects to determine whether they are transparent, translucent, or opaque. So with this one, Son, you will just identify these things if they are transparent, translucent, or opaque. Even without the experiment, you can totally answer this. Okay, so number one, clear glass is?
Transparent,
Yes. Okay, transparent. Okay, two, mirror?
opaque,
Opaque. Okay, very good. Three, plastic bottle?
transparent,
Transparent. Okay, not really. Okay, so this is?
translucent,
Yeah, translucent. Okay, so when for translucent, just remember if the light that passes through it, okay, is bent or it is changed in any way or it is reduced in any way, that is translucent. Okay. Next one, number four, how about paper?
mm, uh, I think there's a shadow in paper, so translucent,
Translucent. Okay. Okay, not really translucent.
opaque,
Opaque. Okay, very good. Fabric, like cloth, like that. Cloth.
translucent,
Translucent. Okay, please try again.
opaque,
Opaque. Okay, anyway, I understand, Son. Maybe these are really thick paper and fabric. Number six, fingernails.
opaque,
Opaque. Okay, not really opaque.
translucent,
Yeah, translucent. Number seven, book.
opaque,
Opaque. Paperclip.
opaque,
Opaque. Okay, and toothbrush.
opaque,
Opaque. Wax paper.
opaque,
Opaque. Okay, sorry, wrong answer. Okay, so
Translucent.
Translucent. Perhaps because of the wax. Okay, it's quite shiny, so it becomes translucent. Okay, so there you go. And these are the answers. Any questions on?
No.
Okay, good job then. So after light, okay, we'll move on to measuring light waves. Okay. So measuring light waves. Light is an electromagnetic wave. Electromagnetic waves move like ocean, waves rippling along the path. The rippling movement is actually like a wave. So when you say ripple, when people say ripples, they saw ripples, or something is rippling, it creates this curved shape. Okay, multiple curved shapes. You can see these kind of wave even if you don't live near the ocean. Stretch a rope between yourself and a partner. Shake one end of the rope once. A wave moves along the rope toward your partner. The audience wave at a football or baseball game is also like an electromagnetic wave. On the internet, oh, this is the most accurate, okay, according to what I've searched, this is one of the most accurate representation of light waves moving in space. So even though it's a wave, okay, the blue color represents its straight direction or straight trajectory. Okay, so these are the light waves. Take note though that this happens extremely fast. Okay, it moves very fast. Okay, it's not really this slow. Okay, next part. Okay, now we have the wavelengths. Okay, you can see here too. So a wave's length is the distance from one crest or peak to the next crest. For example, this pattern shows a short wavelength. Okay, so if you can see that the ripples are closer to each other, okay, they're closer, this is a short wavelength. The other one, this pattern shows a long wavelength. So you can see that the waves or the ripples are further from each other and they are more stretched. You've learned that white light is composed of 7 colors. Okay, remember Roy G. Biv, okay, for the rainbow? That stands for red, orange, yellow, green, blue, indigo, and violet. Each of these colors has different wavelength. So red light has the longest wavelength with about 30,000 waves per inch. So of course, if the wavelength is longer, okay, the frequency is actually lower. So the number per inch, the number of waves per inch is lower, okay, if the wave is longer. And of course, violet light has the shortest wavelength. So of course, the ripples are closer to each other, so there will be more waves per inch. Okay, do you understand, Son?
Yes.
Yes, okay, very good. Can you help me out a little? Can you please read this on? Yes, okay. So I've watched a documentary before, and actually the study of light can affect our travel in space. If humans are able to understand light, its speed and frequency, this might translate, okay, or be converted, this knowledge can be converted into space travel or transportation. Okay, they just say, okay, the main problem is actually the power source. We don't have a power source to power machines with this concept. Okay, so maybe 100 years or maybe 200 years, maybe we can. Okay, so there you go. So it talks about frequencies. Okay, the meaning of that is how many waves passes in 1 second. Okay, so scientists can actually count that. Okay, let's see if they have it in the next slide. So here, so frequency of the waves. So what frequency is your favorite radio station? The number tells you something about how the radio waves travel. Frequency is the number of waves that pass a point in a certain period of time. Since light travels in waves, it's also measured in frequencies. So frequency From the word itself, it means it is how often something happens. Okay, I prepared something for that. Okay, so here you go. So of course, for bigger wavelength or for longer wavelength, the one at the bottom, okay, maybe it makes you a little bit dizzy. So anyway, if the waves are far further from each other, okay, they have less frequency. Of course, it needs to travel, okay, a wider space or area, okay, even though we can't see that. So if the wavelength is smaller or shorter, yeah, of course there will be more frequency. Okay, there will be more movement because it is just closer with each other. So this is wavelength and frequency are inversely proportional. Okay, so there you go. Do you get it, Son?
Yes.
Okay, very good. This will appear in your quizzes. Okay, next part. Okay, we also have the cycles. Okay, this is connected with frequency. So frequency is measured in cycles per second. Cycles are the same as waves. So something that has 3 cycles per second has 3 waves go by in 1 second. Okay? So 3 cycles in 1 second. That's also the same with 3 waves in 1 second passing by. Okay? In a space provided. So the different colors of white light each have their own frequency. Okay, so each color in the spectrum of light has their own frequency. So for example, red light sorry, red light has the lowest frequency at, okay, can you read these numbers on?
Mm,
Yeah.
no.
Okay, that's all right. So we have million, billion, oh, 1,000, million, billion, trillion. Okay, so this is about one, two, yeah, 430 trillion cycles per second. Okay, so that's a lot of wavelengths, okay, in 1 second. Okay, but violet light has the highest frequency. It's almost twice. Okay, so 750 trillion cycles per second. Okay, so that's the amount of waves or cycles that passes through for each second. So which of these two colors have the longest wavelength? Okay, remember at lower frequencies, fewer wave peaks go by. That happens because the waves are longer. Okay, so this is actually longer. Okay, the one with lesser cycles per second. The one with more cycles per second, that is with the short waves. That happens because the waves are longer. Red has the lowest frequency and it has the greatest wavelength. Radio waves have long wavelengths and are found at a low frequency on the electromagnetic spectrum. Gamma rays have very short wavelengths and have a high frequency. Okay, so that's the idea, just like this one. Okay, wait. Do we have more? Okay, next, part 5. This is just an experiment. You don't need to do it anymore. Instead, okay, let's try to finish the lesson sign. So in number 1, drop down list style again. Blank tells the number of waves that pass a point in a certain period of time. What do we call that, son?
Mm, wavelength.
Wavelength.
I don't know. Frequency.
Yeah, okay, frequency. Yes, good job. Number 2 is the distance from one crest or peak.
Wavelength.
Yeah, okay, distance, so length. Okay, number 3, frequency is usually measured in,
Cycles per second.
yes, very good. Shorter wavelengths have what frequencies?
Mm, lower. I mean, higher.
Yes, higher because they're closer. Okay, so longer,
lower.
Yes. And that's it. Any questions on?
No.
Okay, so that's it. That's the end of the lesson. We're able to do two. Son, please don't forget to answer the quizzes in each of our lessons today. If you can't find the code, just message me, okay? Okay, so Son, that's it. I'll see you again next time. Goodbye.